Have you ever wondered about the colossal feats of engineering hidden deep beneath the Earth's surface? Welcome to the awe-inspiring world of tunnel megaprojects, where human ingenuity and the power of technology converge to create marvels of modern engineering. These are not your everyday tunnels. They are gigantic, complex and intricate structures that burrow through the heart of our planet, overcoming geographical barriers and geological challenges. These megaprojects are not simply about connecting two points. They bind together cities and even nations, becoming lifelines that facilitate trade, transport, and travel. They symbolize our relentless pursuit of progress, our ability to adapt, and our unwavering resolve to overcome obstacles. From the bustling ports of the Thames to the snowy peaks of the Swiss Alps, these tunnels are a testament to the remarkable capabilities of human engineering. So, are you ready to delve deep and explore some of the most impressive tunnel megaprojects in the world? Our first stop takes us to the 19th century, to the world's first tunnel built beneath a navigable river. Beneath the bustling waterway of the River Thames in London, lies an engineering marvel that has stood the test of time. The Thames Tunnel, completed in the year 1843, was the world's first tunnel constructed under a navigable river. This impressive feat was achieved through the sheer ingenuity of its creators, Sir Marc Isambard Brunel and his son, the legendary Isambard Kingdom Brunel. The construction of the Thames Tunnel was not without its challenges. The soft, waterlogged ground made for perilous working conditions, and workers had to dig through the earth using a pioneering shield technique that Brunel himself invented. Several floods and a high financial cost led to numerous work stoppages, making the project a 20-year endeavor. Despite these hurdles, the Thames Tunnel was a resounding success, serving as a pedestrian walkway and later as a railway tunnel. It was a marvel of Victorian engineering and a testament to human resilience and ingenuity. The Thames Tunnel's significance in the history of engineering cannot be overstated. It marked the advent of modern tunnel construction and served as an inspiration for many future tunnel megaprojects. Its innovative techniques and daring execution paved the way for the development of modern tunneling technology. An impressive feat for its time, the Thames Tunnel laid the groundwork for future tunnel megaprojects. Fast forward to the 20th century, we venture beneath the English Channel. Emerging from the depths of the Earth, the Channel Tunnel, or Chunnel, as it's affectionately known, is a marvel of modern engineering. This undersea tunnel links Folkestone in the United Kingdom with Coquelles near Calais in northern France, bridging the gap between mainland Europe and the British Isles. The construction of the Channel Tunnel was no small feat. It spans a staggering 37.5 kilometers underwater, reaching a total length of 50 kilometers. At its deepest point, the tunnel sits 75 meters beneath the seabed, making it the longest undersea portion of any tunnel in the world. But the length and depth of the Channel Tunnel aren't its only impressive features. The construction process itself was fraught with unique challenges. Drilling through the earth beneath the English Channel posed significant geological difficulties. The chalk marl, a soft grayish-white limestone formation that the tunnel had to pass through, was both a blessing and a curse. It was easy to tunnel through but also prone to flooding. To overcome this, engineers used gigantic tunnel boring machines, some as long as 2 football fields, that not only dug the tunnel but also lined it with concrete segments to prevent collapses. The Channel Tunnel isn't just an engineering marvel, but also a symbol of international cooperation. It was built simultaneously from both the French and British sides, meeting in the middle with less than 2 centimeters discrepancy. This achievement was the culmination of over 200 years of planning and 6 years of construction, involving more than 13,000 workers. Today, the Channel Tunnel stands as an indispensable artery of transportation, facilitating the movement of millions of passengers and tons of freight every year. It has not only transformed the way people travel between the UK and mainland Europe, but also fostered closer economic and cultural ties. The Channel Tunnel, a symbol of international cooperation and a testament to human ingenuity. Now, let's travel east, beneath the Tsugaru Strait in Japan. Here lies an incredible feat of engineering and human resilience, the Seikan Tunnel. This undersea tunnel is among the longest in the world, stretching an impressive 53.9 kilometers, or 33.5 miles, under the seabed. The Seikan Tunnel is no ordinary tunnel. It was constructed in response to the tragic sinking of a ferry during a typhoon in the late 1950s, a disaster that claimed the lives of over 1,000 people. This sparked the need for a safer, weatherproof way to connect the islands of Honshu and Hokkaido. The construction of the tunnel was an enormous undertaking, The work began in 1964 and took a staggering 24 years to complete. During its construction, the engineers faced a multitude of challenges. The seismic activity in the region was a significant concern and necessitated the design to be both robust and flexible enough to withstand earthquakes. The tunnel was carved through solid rock beneath the seabed, where the engineers contended not only with the technical difficulties of tunneling, but also with the constant threat of seismic activity. Despite these challenges, the engineers pressed on, driven by a determination to create a safe passage between the islands. Today, the Cenis Tunnel stands as a testament to the incredible resilience and ingenuity of its builders. It plays a vital role in Japan's transport network, facilitating the movement of people and goods between Honshu and Hokkaido. Every day, freight and passenger trains traverse its length, moving seamlessly beneath the seabed. The Cenis Tunnel is more than just a means of transportation. It represents the triumph of human ingenuity over nature's barriers. It is a symbol of perseverance and determination, a monument to those who lost their lives in the ferry disaster, and a reminder of the lengths to which we can go when we are driven by necessity and determination. The Cenis Tunnel, a marvel of engineering resilience in the face of nature's unpredictability. Our final journey takes us deep into the heart of the Swiss Alps. Imagine carving a path through the very core of the mountain range that has symbolized both natural beauty and formidable challenge. That's exactly what engineers did with the Gotthard Base Tunnel. With a length of 57 kilometers, it holds the record for the longest railway tunnel in the world. This colossal project didn't come to fruition overnight. It took 17 years of tireless work, from the first excavation in 1999 to the first train ride in 2016. Over 2,000 workers played their part in this remarkable achievement, drilling through 152 kilometers of rock. The alpine geology presented its unique set of challenges, encountering varying rock compositions, high-pressure water inflows, and extreme temperatures. The engineers had to be as hardy as the mountains they were tunneling through, yet they persevered, pushing the boundaries of engineering and technology. But why go to such lengths, you might ask? The Gotthard Base Tunnel plays a pivotal role in the European freight and passenger railway network. It reduces the travel time between Zurich and Milan by a full hour and increases the freight capacity across the Alps. It's an essential artery connecting northern and southern Europe and facilitating the smooth flow of goods and people. This tunnel isn't just a marvel of engineering, it's a testament to human resilience. It's proof that with determination, ingenuity, and a whole lot of dynamite, we can overcome even the most daunting obstacles. This tunnel is more than just a passage through a mountain, it's a symbol of progress, a beacon of human achievement. And so, as we emerge from the darkness into the brilliant Swiss sunlight, we leave behind a monument of steel and concrete carved into the very bones of the earth. A journey that began deep in the heart of the Swiss Alps ends in admiration of an extraordinary feat. The Gotthard Base Tunnel, a testament to the limitless boundaries of human engineering. From the Thames to the Alps, we've journeyed through time and space, exploring the marvels of tunnel engineering. We've seen how the Thames Tunnel, once dubbed the eighth wonder of the world, paved the way for modern tunneling, overcoming daunting challenges of the subterranean world. Next, we crossed the English Channel via the Channel Tunnel, a feat of engineering that defied the sea, connecting two countries and fostering international unity. The unique challenges faced and overcome here were nothing short of awe-inspiring. We then ventured to Japan and into the Cenis Tunnel, the longest undersea tunnel in the world. This marvel of engineering, born from a tragic ferry disaster, stands as a testament to Japan's resilience and innovative spirit. Finally, we climbed the Swiss Alps to marvel at the Gotthard Base Tunnel, the longest railway tunnel in the world. A symbol of Swiss precision and efficiency, this tunnel showcases the pinnacle of modern tunneling technology. Each of these megaprojects, unique and impressive in their own right, have made significant contributions to global infrastructure. They've pushed the boundaries of what's possible, overcoming geographical barriers and fostering connection and cooperation between nations. These impressive tunnel megaprojects not only connect geographical locations, but also symbolize the indomitable spirit of human ingenuity and ambition.